Okay, now that you have the estimated latitude and longitude, we move to the celestial triangulation tool, the map of what I'm depicting the two-pole celestial disk look like. So you would just use this like any other grid map. You would just find your latitude and longitude on the grid, which would be 96 by 36. So you just count over 15 degrees for each line. You start um, 30 degrees off on my map since I've moved the prime meridian back to Egypt, whereas we have it at Greenwich. So you just have to start here with 0. So you add up your latitude and longitude and find out where you're at. We're going to be right here. I've already marked them, mark on the edge so we can get an exact angle from the Polaris or the North Pole so that when we take all this off and start putting the stars on, we can line it up real easy. So now we take off the grid overlay and we have star overlay on it. And now you can only use one star uh, disk or spherical disk at a time whenever you're triangulating, whether you're in the northern hemisphere or the southern hemisphere. So we're in the northern hemisphere. We're going to put on the northern star disk and turn it to where north is up from you and where you're positioned, that line is down. And now you're going to have to go outside. Well, actually, there's one other thing. You're going to need the overlay to show the observer's viewpoint. This one is for a 35-degree latitude since our latitude's 36. This is the closest latitude you're going to be able to get between 10-degree latitude changes on these overlays. So you put the overlay on. Oh, I got to flip it over. One side south, one side's north as it inverses whenever you go by. But so you put this, you can see this line down here for the observer. You line it up with your line, and then now you're going to have to spin these stars. Here, I'll go ahead and turn it the other way so you can have this, and you can see now you're going to have to go outside and spin these stars to where it's what you see above you. And I can show you that as far as if I just show you what the stars will look like outside. I'm going to have to pause this. So you can see that the North Star's right there at the bottom. You've got Cassiopeia at the top, and then Capella off to the right. It's just off screen, actually. It's just, you can't actually see it, but you can see Cassiopeia, the M or the upside down W constellation right at the top of your screen in the middle. That's what we're going to use to go ahead and show what the stars look like on ours. So I'm going to go ahead and remove this so you can see what's happening. But you would take and you would put your stars on there. And Cassiopeia's star that we're looking at is called Schrader. And it's going to be right here. And you're just going to line it up in between north and your line. And you just get it on there and you can see that you're at a certain number. It doesn't really matter. It just makes it easier for you to know the number that you're at to be able to line that up with north. We're going to say 7. So now we can put the overlay back on. We line that line up on the same line as this. And now we can see the stars we're going to use, not Schrader, not the one that's directly above us, but the ones that are off at least at a 45-degree angle or somewhere thereabouts, 35 to a 65 degree angle from you, either off to the east or off to the west. But we have Capella here, and Capella is showing that it is at 55 declination. As far as this overlay right here shows you declination so that you can figure out your amplitude. So you would go ahead and take this, write down your 35, or I'm sorry, what was it, 55? Hold on, what a second there. Yeah, 55 for Capella. Now you would go outside, you would use a compass, just straight up compass, and you go outside and you'd point it at Capella and you'd see what reading you would get. And most likely you're going to get, if that's showing a 55, you're going to get like a 62. And that's going to give you your, that 62 is going to give you your amplitude as far as how you're going to triangulate your position. So you just have to take away 55 from 62, and then it'll give you 7. So you know it's 7 nautical miles or 7 nautical minutes, however you want to, or 7 minutes. Um, it's arc minutes, I'm sorry, 7 arc minutes or 7 arc miles, that your amplitude is going to be for this collection. So now you would have to go away from this map and you go to your triangulation. You know that your latitude was 36. You know that your longitude was 95. So that's going to be your base, your estimate, and that's going to be the middle of this cross, and that's where you're trying to triangulate. If you're triangulating for um, to actually write this down, you're going to need to draw out from the center to the angle. So this one was 62. It's always the one that you use with your magnetic compass, not the one that it shows on the graph. So you got to go to 62, draw a line along 62, and label it Capella. Now you know that you're at the 36th parallel. So you go down to your graph down here, the measurement, and you draw a line on the 36th line, on the 36th mark. And that gives you to where that's where you're going to measure your graph, because you know that your latitude is a 36, so your box is a 36 by 95. It's not within this graph or this graph, it's going to be right in this line. So now you know you need 7 amplitude to see what your or 7 nautical miles to see what your amplitude is going to be off of Capella. So you measure that out. For each one of these lines, it's 2. For each one of these big lines, it's going to be 10. So you just estimate it out. You go up on your line. You draw a 90 degree horizontal line from the line off of Capella or off the star you're shooting. And now you know that somewhere along this line is where you're going to end up your fixes. This is your estimated position somewhere along here. Now you need to shoot one more, and that's very easy. You just go over to another star on your map, and you want to pick it. Usually if you're going over to 45 this side, you're going to want to pick one over here. So let's just go with Vega. Vega's showing that it's at 335. Vega's at 335. And you go out and you shoot it with your compass, and you find out that Vega's actually showing you that it is at 340. So you know already that you're just going to remove that away from it. So that's going to give you 5. It's going to give you a 5 amplitude or 5 nautical mile difference. So now you go back to your triangulation. You're going to go and put your line down for Vega at 340. Then you find out your amplitude, which is 5. So you go estimate that out. You go up the line of Vega, and you draw your 90 degrees. So now you know that you're along that line somewhere is where your fix is. So now where those two meet is your fix. And that's going to be a close estimate or a triangulated position of your latitude and longitude using the celestial triangulation tool with the stars.